G'day everybody, how's it going? Well, we're finally getting started on a 3RZ swap in the BMW. In this video I'm going to do as I did with the 5VZ swap, which I did in my mate's 4Runner. So I'm going to compile together most of, if not all of the information necessary before starting the job into this video. And this video is going to pretty much act as our job plan of sorts to give yourselves and myself pretty much most of the guidance needed for what I'm going to partake in this job. So the Patrol's up and running now. I've retuned the engine and it's running so much better with the new turbo on, man. I've chucked a bunch more fuel at it and the exhaust temps are still pretty low, meaning I'm making a bunch more power and not at the risk of destroying my engine with hot temps because the turbo's much bigger and not acting as a big hot air blower into the engine. But anyway, enough about the Patrol, let's get into things with the BMW. So I decided a while ago, when I still had my Hilux, that I wasn't going to go to the effort of building my Hilux into the drift car that I wanted. This is because the Hilux would have needed a 4-link rear axle and a whole bunch of work to get it to where I wanted it as a drift missile. And that just wasn't going to be viable time-wise and money-wise for the amount of enjoyment I got out of driving the car. So I decided that I was going to start looking around for a new canvas or a new shell to put my 3RZ into. And I stumbled across the BMW E39. So I got my hands on a BMW 525i E39. This came with a 2.5 litre M54B25 straight 6 engine, and this was also coupled up to a ZF 5HP 19 5-speed automatic. The engine itself was in pretty poor health, which made the car a good viable choice for the engine swap, so I didn't really feel like I was butchering up a nice car. So I went ahead and removed the engine and gearbox, because I'm also going to be manual swapping the car when I put in the gearbox that I've acquired for it. As I said, my end goal with this car is to build a wicked drift missile, and so having a manual gearbox is going to be quite nice for that. So for the gearbox itself that I'll be running, I found an R150 Toyota gearbox out of a 7th gen Hilux. The R150 found itself behind the 2TR FE, which was the replacement for the 3RZ FE. This was the new petrol engine that they offered as the base model for the Hiluxes starting in the 7th gen, which is the generation after my Hilux. What makes it nice and easy about this is that the 2TR FE engine has the exact same bell housing bolt pattern as the 3RZ, meaning that I could get the 2TR gearbox and its bell housing, and that's just going to mate up perfectly to the 3RZ. Most of the reason why I chose this R150 is the fact that it's easy, it's just a bolt-on because it comes with the right bell housing. But the R150, as compared to the W56 gearbox that was in my Hilux originally, it is a whole lot stronger. So it has a stronger housing, larger main and output shafts, all the gears are physically bigger, as well as 5th gear is supported by bearings on both sides rather than just one side. So overall it's a lot of a stronger gearbox. It's from the same family of gearboxes, the R154 or the R series gearboxes that came behind the 2JZ. This goes to show that it was a good design because Toyota itself decided to engineer the gearbox behind engines like the JZ. General consensus from the Toyota Supra community is that the R154 will hold up to 700 horsepower. I feel like anything above that's going to be hit or miss. It varies greatly on your setup and whether you're just spinning tyres or you're actually gripping up with drag slicks, because that itself will put more load on the drivetrain and the gearbox itself and may lead to premature or earlier fails rather than something that's just spinning wheels and not really loading everything up. The other benefit of the R series gearbox family is that the R150 that I'm going to be using, I'll be able to get bell housings for the 5VZ, the 1UZ, the JZs. As I said, there's going to be a lot of options with it, potentially, depending on if I pop this 3RZ and want to move to something else. I'll have the ability to sort of branch out and choose different things down the track should I want to go that way. But anyway, let's not get too ahead of ourselves. The current job, as I've said, is installing the 3RZ into the BMW and getting it running. Unfortunately, it's not as simple as getting the tool gun out and using the weld feature into the car. The 3RZ is a completely different engine from a completely different manufacturer compared to the BMW's engine that I've just yanked out. So we may and probably will run into issues, but that's all part of the job of an engine swap, is working your way through these things. So, the first things that we're going to consider is power steering and charging systems. These are auxiliary systems that the car requires to work well and properly before even considering getting the engine drivable. Both of these systems intersect into the vehicle itself from the engine, meaning that we need to get these sorted out and working properly to avoid dramas like bad earths or batteries cutting out or alternators exploding, that kind of thing. First thing we'll do is we'll start with the power steering system. So the BMW uses a fancy rack and pinion steering system. This is a huge upgrade from the good old steering box and drag link that the Hilux was using. Rack and pinion systems that the BMW uses are much more compact and much more responsive than the latter, hence why the one in the BMW is there. It's been engineered and designed by the team of BMW to make it a usable and good steering rack in a sporty, if not racing-worthy car. Both of the systems are hydraulic, meaning they require pressure to actuate the system correctly. Pressure is delivered from a hydraulic power steering pump driven by the engine in both applications. So our plan is to retain the factory 3RZ power steering pump and use it to supply power steering fluid to the BMW steering rack. When you're retrofitting equipment in place of another, all of the operating parameters need to be taken into account. So if we have a look at this schematic that I drew up to show how powering steering system works, we'll see that the reservoir as well as a relief valve is built into the power steering pump. The relief valve opens and bleeds pressure out into the reservoir. This will stop overpressurization of the system and damage to the steering rack or the steering seals inside the system. So I've looked around online, and what I've found is that the BMW power steering pump for the M54B25 engine comes with a sticker on the sides stating 120 bar. 120 bar converted to PSI is 1740. I would take this and make the assumption that this is the max allowable working pressure, or the max pressure that this pump is going to supply before the relief valve kicks open. Every single power steering system is going to have a relief valve, and it's natural that it'll be built into the pump. If we have a look at the Haynes service manual for the Toyota Hilux, it states minimum output pressure 8,336 kPa. This, of course, is 83.36 bar, or 1,208 psi. Note that says minimum. So that itself is probably the minimum output pressure at low RPM and high fluid temp. Since this is lower than the maximum allowable working pressure of the BMW system, this means I'll be able to hook the Hilux power steering pump straight up to my steering rack. The output pressure is slightly lower than the BMW's pump pressure. So what this may mean is there's a slight bit more force required to steer the whole system. However, there will be hydraulic pressure there to give us the aid and the assistance within the system. What this does mean is, although slightly lower than BMW pumps are, the Hilux pump's going to create enough power steering pressure to give us assistance while steering and mean our power steering works to an extent. Next, what we're going to move on to is the starting and charging system. This is where things are going to get a bit more intricate and going to start confusing people. Don't worry though, at the end of the day, it's literally just a battery and it's a one-way flow of current or electrons, so it's not that easy to mess up as long as you pay attention. The 3RZ used a 70 amp alternator. From what I've read online, the BMW alternator is rated at 120 amp. So this shouldn't, I'm going to say shouldn't in brackets, be a problem. The BMW alternator is a higher amperage because it's there to keep everything charged from the BMW accessories side. So this includes everything like the airbag ECUs, the engine ECUs, the automatic transmission ECU, the little air pump inside the ECU box, and yeah, just all of the electronic systems inside the BMW required to make it run. There's a lot more stuff to be drawing current than there was that was in my Hilux, hence why the amperage of the alternator needs to be a bit more. Now that we're swapping the Hilux engine into it though, we've removed a good deal of that, so the automatic ECU, the engine ECU, a bunch of other stuff, and hopefully get it drawing a little less current from the battery while it's running. This could be a problem down the track, but for the early R&D of this setup, we're just going to run the Hilux alternator and hope for the best. So, the starter motor and the alternator are connected to the same big, thick gauge, unfused power wire. You can call this a bus wire, but yeah, just a positive wire. So this wire is what the starter motor pulls all its amps through. This has to be a thick wire because starter motors will pull like 400 amps from the battery. If you have a look on your battery, there's a CCA stamp on the top, which means cold cranking amperage. The battery that was in my Hilux is rated for 600 CCA, so 600 cold cranking amps. Now, since the starter draws its current on the same wire that the alternator is going to feed the power back into the battery through, you don't have to worry about a fuse. It's just this super thick gauge wire that you don't even have to worry about melting because it's so big. The Hilux did have a 100 amp fusible link between the alternator and the main bus wire, so going off what the original wiring diagrams were, I may fit something in just to have it as close to factory build as it would be to stop problems. The alternator also has a few wires that come off it. These include the light for the dashboard to show if the alternator is not charging the battery, or the alternator dummy light. There's a second separate 12 volt wire from the ignition. This wire is known as the remote sense wire, and it was in the 3RZ as well as the BMW with a 7.5 amp fuse input. This should be from the same wiring loom that feeds all of the accessories in the cabin, so the ECUs and the lights and stuff. That's because this wire is a voltage reference input to the alternator. When the alternator feeds the battery along that big thick gauge wire, there's going to be some amount of voltage drop between the alternator and the battery. And so to avoid discrepancy in what the alternator feels the battery's current voltage is, this sense wire allows the alternator to see the current voltage of the battery itself and adjust its input of current to the battery accordingly. So, the starting and charging systems and the power steering systems are covered. These two systems are the ones that leach into the vehicle that I was talking about. So with these systems covered that intersect into the vehicle's chassis itself, we can now start looking at the entire assembly that we'll be fiddling with, the entire drivetrain. There's a lot of stuff that I've already used on the Hilux build that I'm going to be fitting in, such as the ECU wiring loom, the engine harness and the ignition coils, so we don't have to worry about a lot of stuff. Our biggest problems are going to be mounting the engine in with engine mounts and transmission mounts. And then the other big thing is going to be getting a custom tail shaft made with a front end or a front yoke that's going to go into the Hilux gearbox and then connect up to the BMW differential. So that covers everything that I wanted to talk about in this video. The reason why I'm not touching on the things like the engine and transmission mounts is because I'm 100% sure that we're going to be able to make something work. I wasn't 100% sure about the compatibility between the BMW's inbuilt systems of the power steering and the starting and charging when compared to the 3RZ. So I wanted to give myself the background information and certainty that it would work, as well as everyone else that's going to be following along with this build. I'm sure that I'll be able to make the gearbox and engine work in this car. Fabrication is one of those things where whatever you put your mind to, you can do, provided you have the time and the effort. Anyway, that covers everything that I wanted to in this video. I hope everyone's enjoyed it. This build's going to start ticking along slowly. I've got a bit more spare time now. As always, I think I've mentioned before, it's really difficult juggling two project cars, the Nissan Patrol and this BMW now. But there's going to be content rolling out for both of them. I may get the Patrol on the dyno soon to see if the new HE221's done anything to adjust the power. But apart from that, we're going to keep plodding along and you'll keep hearing from me in the relatively near future. Thanks everyone for watching. Again, as always, if you have any questions, feel free to comment, leave a like. You can find me on Instagram. I'm going to be posting a little bit more often now. And I hope everyone's had a good day. Hope everyone's enjoyed this, and I'll see you all in the next video.